Now function fx is equal to cos x minus 2 lambda x is monotonic decreasing when? What does it mean? Decreasing. That is, it is less than 0. So f dash x greater than 0, it is increasing. F dash x less than 0, it is decreasing. F dash x is simply differentiation. So we are differentiating it right now. Cos x is minus sin x. Minus 2 lambda x is minus 2 lambda. So this is monotonic decreasing. So it is less than 0. So we are not dealing with negative. So I'm taking minus outside. It is less than 0. Multiplying both sides by negative 1. The inequality sign is going to change and the negative sign will become positive sign. So this inequality will change. It will remain 0. This is going to be sin x plus 2 lambda. So this 2 lambda is greater than negative sin x, and then we have this negative, just multiply this one, negative 1. So when you multiply this negative both the sides, let's make it positive because dealing with this negative creates certain problem. So minus 2 lambda is less than sin x, and this sin x, see again, sin x is between negative 1 and 1. That is the highest and lowest range of sin x is negative 1 and 1. So this x is less than sin x, or say y is less than sin x. What does it mean? Something is less than the minimum value of sin x. What is the minimum value? Minus 1. So minus 2 lambda is less than minus 1. Again multiplied by negative 1 on both the sides. So this inequality will change. It is going to be 2 lambda 1. So lambda is greater than half. So this lambda is greater than half is the option being provided, and that is what we are going to use. So this is how you are going to go about it. So this dealing with negative may create certain problems. So always get rid of negative and then solve the way we have solved it here. Just differentiation and getting it greater than 0. In the interval 1 to 2, function fx is this. First thing is that we are talking about 1 and 2. How this 1 and 2 has come? Because the modulus has x minus 1 and modulus has x minus 2. So x is between 1 and 2, it is given in the interval. That is, anything has to be greater than 1 and less than 2. So x is greater than 1 and x is less than 2. When you take 1 on the left, you will get x minus 1 is greater than 0. Here you will get x minus 2 is less than 0. So we haven't gone to the question yet. I am just talking about interval right now. And from that we got x minus 1 greater than 0 and x minus 2 less than 0. And you know mod x is x when x is greater than 0 and mod x is negative x when x is less than 0. This is the definition of this mod x. Coming to mod x minus 1. See, x minus 1 is greater than 0. I just showed it. So x minus 1 modulus is x minus 1 only because x minus 1 is greater than 0. Mod x minus 2, it is less than 0. See, this is going to be minus x minus 2 because it is less than 0. It is already, I've showed that the value is between 1 and 2 only. So these two you have to replace. Mod x minus 1 by x minus 1 and mod x minus 2 by negative x minus 2. So 2 into x minus 1 plus 3 into negative x minus 2. I'm writing it x minus 2 here. Okay, what do we get here? 2x minus 2 and this is minus 3x and plus 6. So what do you get here? 6 minus 2 is 4 and 2x minus 3x is negative x. So it is 4 minus x. fx is 4 minus x. Now let us differentiate it now. This is interval. We have removed the modular sign. Now coming to the differentiation. When we differentiate, you will get minus 1. Now minus 1 in any cost is negative only. Negative 1 is less than 0. So when we have x between 1 and 2 and we got f dash x which is negative 1 which is less than 0. That means, see, it is not less than equal to 0. It is actually less than 0. That's why it is monotonically decreasing because it is less than 0. F dash x, if it is less than 0, then you can say that it is monotonically decreasing. This is how you are going to do this. This is the whole process you are going to follow. So there are certain things which I have added up and you can just draw the diagram and show. It would be very beneficial for you if the diagram is being made. Function fx equals to x cube minus 27x plus 5 is monotonically increasing when? So the question is saying that it is monotonically increasing. So the concept here is, we'll differentiate first. That is the first thing we do. F dash x is 3x square. This is minus 27. So 3 you can take outside. It will be x square minus 9. And this is x square minus 9 is simply x square minus 3 square. That is x minus 3 into x plus 3. A square minus b square is a minus b into a plus b. So x minus 3 into x plus 3. This is your f dash x. Now this is increasing, monotonically increasing. So it is greater than 0. 3 into x minus 3 into x plus 3 is greater than 0. And you know now 3 is, there is no point in discussing 3 because it is already positive. X minus 3 will be 0 when x equals to 3. X plus 3 is 0 when, because x is equal to minus 3, then only 1. So we are going to write 3 and minus 3. I've just written it negative 3. I'll just change it. Okay, there is a slight change I'll make. But if you see a into b is greater than 0, a and b are the factor. That is anything which is below minus 3 and above plus 3. That is what is the answer will be. If it is less than 0, a into b is less than 0, then we take things which are inside between 3 and minus 3. So we have two ranges here, or two intervals. Negative infinity to negative 3, I'll just change it here, and positive 3 to positive infinity. So minus 3 to minus infinity to minus 3 and 3 to infinite, or you can say this x is less than minus 3 and x is greater than 3, which is the solution when we have two factors multiply, one is plus and one is minus. So x less than minus 3 and x greater than 3. Now take the modulus. When you take the modulus, this x will become again greater than 3. You know about that. A modulus, there is no point in discussing modulus of a positive number here. 3 is a positive number, but negative 3, if you take the modulus, the inequality is going to change. So both the times you are going to get mod x is greater than 3. Okay, because mod x is x when x is greater than 0, negative x when x is less than 0. That shows that mod x is greater than 3. So all this solution has given us what? It's x mod x is greater than 3. There are four options here. X is less than minus 3 is the solution. X less than equal to minus 3 is not. Mod x is greater than 3 is the solution. It's not greater than equal to 3. Second option may be chosen. Fourth option should be chosen. So it is monotonically increasing, that is why it is greater than. 2x cube minus 9x square plus 12x plus 29 is monotonically decreasing when? So when we are decreasing, what do we do? It's fx. We'll take the differentiation. It is going to be 6x square minus 18x plus 12. Now take 6 outside. You're going to get x square minus 3x plus 2. So x square minus 3x plus 2. X square minus x minus 2x plus 3. X minus 1. And you can take minus 2 here. So you will get x minus 1. So x minus 1 into x minus 2. So this is quite easy now. X minus 1 into x minus 2. So 6x minus 1 into x minus 2. It is monotonically decreasing. So just make it as less than 0. And when I told you that we have two factors, 6 cannot be less than 0. So whenever if this x minus 1 is 0 is x equals to 1, x minus 2 equals to 0 is x equals to 2. So 1 and 2 are the critical points. So whenever we have two factors which is less than 0 when they are multiplied, we always take the things which are between certain values. I told you when it was greater than 0 in the previous question, I told you that less than 1, that is negative infinity to 1, and 2 to infinity. That was the point, that was the explanation there. But now here it is less than 0. X minus 2 and x minus 1 into x minus 2 is less than 0. So we'll take a 1 and 2 is the interval. So x lies between 1 and 2. And so this is the monotonically decreasing when x is going to be between 1 and 2. That is going to be that. So this is the whole process you are going to apply here. And this is quite an easy question for you. So this question, fx is monotonically increasing in every interval then. So these are the different options you have. Monotonically increasing in every interval. So the first thing what we do generally, tell me, we just differentiate it. So we are going to differentiate it here also. This f dash x is equal to 3kx square minus 18x, and then we have plus 9. So I'm taking 3 outside. You'll get kx square minus 6x plus 3. Okay. This monotonically increment means what? F dash x should be greater than 0. This whole should be greater than 0. 3 cannot be less than 0 or greater than 0. It is a constant. It is already greater than 0. So kx square minus 6x plus 3 should be greater than 0. Okay. So since the value is not given, so here we'll use the concept of the determinant. See, there are certain things which comes up in the question which is different from what we have been doing. So if we have ax square plus bx plus c is the quadratic equation, if it is greater than 0, what does it mean? It means a greater than 0, a should be greater than 0, and determinant, which is b square minus 4ac, should be less than 0. Two things here. I have introduced a new concept which we have already discussed in the previous chapters. So a should be greater than 0 and b square minus 4ac should be less than 0. Okay, what is a here? K. B is minus 6. C is 3. If you compare this equation, quadratic equation, with ax square plus bx plus c, you will get this thing. So we'll just say that this k should be greater than 0 because a is greater than 0 is the first thing which I told you. Second thing is b square minus 4ac should be less than 0. A is k, b is negative 6 and c is 3, which I can reiterate now. And I'm now replacing the value b square minus 4 into a, that is k, and this is 3. So this is less than 0. 6 is 36 minus 12k less than 0. 36 is less than 12k. 12k, that is k, is 12k is greater than 36. k is greater than 36 by 12, which is k is greater than 3. So when you have two options, k is greater than 0 and k is again greater than 3. So if you combine this, if you're saying something is greater than 0, something is greater than 3, that means it is greater than 3. It's greater than 3 if you combine these two. So k is greater than 3 is the correct option which we are going to choose here. Alright. So this is the step-by-step solution which you can see here. And this thing is a new thing which you must know. Otherwise it won't be able to be solved by itself, right? You have to take these two things into point. F dash x greater than 0 is already there, or less than 0 is already there. Now here the differentiation will take some effort, but monotonically increasing is simple with what we have been doing. We just differentiate it and we take it as greater than 0 because it is increasing. So first thing is f dash x. Let us take the differentiation. 2 tan inverse x is 1 by 1 plus x square. Log content anything is 1 by that thing. So 1 by x plus under root x square plus 1. Differentiation of x plus under root x square plus 1. So it is going to be 1 plus 1 by twice of under root x square plus 1. Under root x square plus 1. Then differentiation of x square plus 1 is 2x. So I've written the differentiation. Now there's only one thing you have to do is to take the LCM and you have to rearrange. You know how to simplify this. So I will just leave it for you because I hope that this is a customary and routine things which you have been doing. I'm going to write the final thing which you get because it will take some certain time to solve it. So I'll just write the final thing. 1 plus 2x square minus under root x square plus 1 divided by 1 plus x square. This is after the simplification. You are going to get this thing only. Now this is greater than 0. This is given in the question. This is greater than 0. 1 plus x square will always be greater than 0. Anything with an even power is going to be greater than 0. So even if you add 1 with x square, it doesn't affect. So 1 plus x square will be greater than 0 eventually. What is the numerator? 1 plus 2x square is greater than under root x square plus 1. This is the what you get in the numerator. Now take the square of both the sides. 1 plus 2x square whole square and x square plus 1. Now just open this. It will be a plus b whole square. So a square plus b square plus 2ab. You can use the formula. There is no extra 2ab. This is a formula. You multiply 2 times, then you get 2ab. There is no extra 2ab. Okay. So what do you get? One gets cancelled. And you have 4x raised 4 and this goes here. It will be plus 3x square greater than 0. And this is greater than 0 because x has even power. One term has x raised 4. One term has x raised 2. X raised 4 and x raised 2. So anything with even power will always be greater than 0. Alright. So this is the x raised to even. Now these both are positive. 1 plus x square was already positive. So whole this numerator denominator or whole term on the left is greater than 0. So if you put anything in the x, this function will always be monotonically increasing. It doesn't matter. So you can put anything, and anything is what? Real numbers. Real number, anything which can be placed on number line. It can be 0.1, it can be minus say 2.3, it can be 1 by 98, it can be any number which can be represented on the real number line. So this real number is the solution. X should belongs to real number. That's how this function is going to monotonically increase. So you have proved that the term on the left when you took the f dash x is greater than. Differentiation will be done by you. Okay. So this will take some effort, but I hope you'll be able to do it. So this is the whole option. This is the whole thing which you are going to do. Alright, so x belongs to R is the answer. Now we have this mod x and mod x minus 1 is monotonically increasing when. So before that, there will be certain cases here. So if you see all these options, very carefully see the 4 options being given. So what do we have? X and x minus 1. When it will be 0, this mod x, when x is 0. When will x minus 1 equals to 0? When x is equal to 1. So this 0 and 1, these are the point on which we can devise 3 cases. So x when it is less than 0, when x is between 0 and 1, and when x is greater than 1. I hope you got the idea. X is less than 0, x is greater than 1, and x is between 0 and 1. So when x is less than 0, this is case 1. When x is less than 0, by definition mod x is going to be negative x. X is less than 0, mod x is going to be minus x. How about mod x minus 1? When x is less than 0, you can just try putting any value because it is less than 0. So it's going to be what? It will be negative. So it will be minus x minus 1. So for x less than 0, you can put any value. Try it also. Mod x minus 1 is going to be minus x minus 1 in this case. Okay, I'm saying if you put -1, say for example, it will be -2. So what will be that? It will be negative of 2, negative of x minus 1. So this case 2, case 3. Again, these three cases I'm going to show side by side between 0 and 1. Now we have come between 0 and 1. X is 0 and 1. We have come to the positive side. So mod x is going to be positive x. But still, this mod x minus 1, you are subtracting from 0 to 1. Any number between 0 to 1, you are subtracting that number. The 1 is being subtracted from that. So it will be negative. Okay. You can put any value. Say you just put say 0.5. So 0.5 minus 1 is negative 0.5. So it is going to be negative. Mod x is going to be positive. I hope you got the idea. Take any value between 0 and 1. Place in place of x. If I take 0.5, it is going to be minus 0.5. So mod of negative 0.5 is going to be negative of x minus 1. Mod forcefully makes a value positive. So you have to place a negative to make it positive. How about this is third thing, which is if you're going above 1, of course, mod x is going to be x only, it is positive. And when you are between above value of 1 and you put any value of value above than 1, say put 2. So 2 minus 1 is 1 and mod of 1 is 1 only. That is mod x minus 1 is going to be x minus 1. So third case we took was x greater than 1. Alright. Now let us differentiate. But for that we have to make the function. Fx is going to be, now we already have the non-mod values. Just replace it. Minus x, minus of minus is plus, x minus 1. So you can cancel this. It is going to be -1. So just differentiate this f dash x. And when you differentiate it, it is going to be 0. And f dash x is equal to 0. It is not greater than or equal to 0. It is equal to 0. I hope you got the idea. So it is you who are going to decide what options you are going to take. Second thing, fx is equal to, now x, in place of mod x minus 1, you can write minus of minus x minus 1. So plus x minus 1. This is 2x minus 1. When you differentiate this, it's going to be 2. So it is not greater than or equal to 0. 2 is actually greater than 0. 2 is actually greater than 0. Now third option is what? Fx. We have x here. Mod x minus 1 is of course x minus 1. So this is again, this gets cancelled. Fx is 1. F dash x is going to be 0. So this is not greater than or equal to 0. It is actually equal to 0. So in the first case and the third case, we got f dash x equals to 0. But in the case number 2, f dash x is actually greater than 0. It is not equal to 0. So there are three options here. First and third option gave us equals to 0. The middle option, which is x between 0 and 1, has given us what? It is actually greater than 0. So what do you suggest? So we have all the options here. Three options we have taken. You can just forget about this x less than 1. So x less than 0, x greater than 1, and x between 0 and 1. All these three options or three cases, we have seen that what options you can choose. If it is increasing or monotonically increasing, there is a difference. There is a difference between increasing and monotonically increasing. The question could have said that it is exponentially increasing. Monotonically increasing has certain value or added this certain value to this question. We have three cases here. 2 times we got equals to 0. 1 time we got it is greater than 0. So what do you think? These are the three answers you can have. These are the three options. But the R.D. Sharma has given it is x. The options which are being provided or the answer which is provided by R.D. Sharma is this. Now you have to decide what options you are going to choose. If it is increasing, we choose x less than 0, x greater than 0 and x between 0 and 1. Alright. So this is the whole say idea or scenario which I want to highlight, that certain questions it's up to you that what options you are going to choose depending upon whether it is a 2 marks question or more than that number of questions. So this is the x between 0 and 1 is the, if you have to choose one, x between 0 and 1 is the best suitable answer. Otherwise, the first, second and third are the better options if you choose all of them. So this is the whole one. It is not monotonically increasing. It is monotonically increasing between 0 and 1. Every invertible function is, so we have seen previously also, every invertible function is what? It is a monotonic function, because in previous question also I told you it was a reverse, that this function is monotonically increasing and the option was f inverse exist or f is function is invertible. So if it is invertible, that signifies or that indicates that we are dealing with the monotonic function. So this is how we are going to write. So this question we will take in the next discussion. Till then, thank you so much. Take care of yourself.